We're going to now move along to what I'm going to term toolbox number 2. This is the toolbox that we were actually working on before we all went on vacation. And so hopefully you still have that toolbox with you. If you don't, again, you can create a new one. Just get a piece of printer paper, and you can either keep your notes on the printer paper, or you could keep notes in Seesaw, or in another format that is useful to you. So what I wanted to do in this video is to review a couple of topics that we worked on in early March. One of them is diatomic elements, coming back to those again. And the other one is the polyatomic ions. And I want to go through again how we determine the charge and the number of oxygens that are present on a polyatomic ion. So to do that, we're going to go ahead and switch over to my other screen. All right, there we go. Okay. We're going to start out with the diatomic elements. Remember that the diatomic elements are the elements that never travel by themselves. So we start with element number 7, which is nitrogen. And remember that there's 7 of them. They form a 7. It looks just like a 7. That's 6 of them plus hydrogen. So remember, when you see any of these, they always have to be written by themselves. You cannot write them with anything other than a 2 behind them. So it has to be, if they're by themselves, N2, O2, F2, Cl2, Br2, I2, and H2. So when they're by themselves, they have to have a 2 behind them. If they're traveling with a friend, they don't need that extra 2 behind them. So that's diatomic elements. We're going to be using those a lot. Now the second thing that we need to go over is also using the periodic table, but this time what we're going to be doing is using the periodic table to identify a new set of ions. In the past, we've always worked with monatomic ions, in other words, where there's only one. So we've taken things like lithium and bonded it to chlorine, and those were 2 monatomic ions. Now we're going to start using polyatomic ions. The polyatomic ions are identified through a process in the periodic table, a pattern called T. I'm going to switch colors over here to blue. 4, and get some green. And I'm going to make kind of a weird looking 3 there. So the T is going to stand for the letter or the number 3. And so for each of these elements, starting at the upper left with boron, there will be 3 oxygens. So bor8, this is bor8. They end in ATE now, if they correspond to T43. So bor8, and the one next to it is CO3. CO3. So that one is carbonate. Notice the ATE again at the end. And the one next to that, nitrogen, is going to be NO3. So nitrate, ATE. So all of those that are in that corner that fall under the purple letter T, they end in ATE, and they each have 3 oxygens with them. The second group, right underneath them, and we'll use that blue, the 4 does stand for 4. So each of these is going to have 4 oxygens. So we'll start with at the upper left of the 4, so phosphorus is going to have 4 oxygens, and its name is phosphate. The one next to it, SO4, would be sulfate, and so on. And then in the green area, the green ones, the ones with the number 3, that's a terrible 3, we'll try that again. 3 also stands for 3. So each of these is going to have 3. So it would be FO3, which is fluorate. So again, ATE. And each one of those under them, so chlorate, ClO3 would be chlorate, bromate, iodate underneath them. So that's how we use the periodic table to identify how many oxygens and how many and what is their name. Now, when we go to determine the charge, we're going to start where we usually do with the halogens, because we know that they're -1, and they keep that charge. They are still all -1, even in their polyatomic form. In that top row, we don't have a charge for oxygen by itself, but all the others in that T, they just start over, -1, -2, and -3. So borate is going to be -3, carbonate -2, nitrate -1. In the second row, they just go in order again, -1, -2, -3, and then back down to -2. So chlorate is -1, sulfate is -2, and phosphate is -3. And in the next row, they still again follow that pattern. So that's all the further we're going to go with those. But now you can see the pattern. I've also provided a chart on Canvas that gives you the charges and the symbols for a variety of the most widely used polyatomic ions.